Sorry about the awkward silence. Thanks everyone for rocking up to the Data Eng meetup. We're actually, my name's Peter Hansons. We've got a really, really good lineup of talks tonight, actually. Troy Sellers, he's a staff solutions architect at Aiven. Who's heard of Aiven before? Not many folks, right? Who's tried to sort of run their own Kafka cluster in production, just, self-installed sort of thing? One of a few people, probably. Is it easy? No. So Aiven is basically a company that helps, roll out sort of, I think Troy will explain it a bit better than what I'll do, so I'll leave it up to him. And then we've got Loy Rao and Harpreet Singh telling us about how they sort of went, they brought NoSQL, created a multi-cloud solution for that. So that's pretty amazing. So here's the talk details for our two speakers tonight. And I just wanted to sort of do a quick shout out for Data Eng Bytes. We're running the conference in the last 2 weeks of August. And we're doing a bit of a shout out for sponsors and folks to get involved. And of course, you can always host a meetup or submit a meetup talk. So just feel free to grab one of those QR codes or reach out to us on that email. We should have 4 cities for Data Eng Bytes this year. Last year, we had 2 cities, Sydney and Melbourne, over 400 people in attendance. It was a fantastic event. You can watch many of those fantastic talks up on our YouTube channel already today. And this year, we're planning to be in 4 cities and have 1,000 data engineers attend. I think it's going to be amazing. The data engineering community here in Australia is literally so strong. And it's in a large degree, in part to our, all of you folks and our amazing sponsors. So we do this not for profit. We're just looking to get sponsors on board, just drive down ticket prices. You'll notice that a lot of, tech conferences these days charge you $1,000 or $2,000 per ticket. We actually charge about $100 or $200. We're just kind of really just trying to make it an accessible conference for all of you folks. So, so feel free to get on board. Very excited to, see how you can sort of help us all out. Stay tuned for more details on that front. But without further ado, we're going to have Troy Sellers present the second talk for tonight. For those of you on the live stream, we won't be able to live stream that just because there's, I think, a few things under NDA or just, so it's just going to be the benefit of the crowd here tonight. But I think it'll be a fantastic presentation nonetheless. So really looking forward to it. Round of applause for Troy to welcome you.
Okay. Some audio. I probably would take the microphone if it's on offer, just so everyone can hear me. I'll put it up there so it's nice and awkward. Makes all that wonderful noise. How is everyone this evening? Start off like I know what I'm doing. Okay, let me just see if I can jump in. Let's see, that doesn't share my screen. Go. No.
Become the main presenter.
Someone help me drive there.
Yep.
Actually, I'll just need give me the whole browser.
Whole browser?
Yeah. Window, the entire screen, that'll do. Rock and roll. Okay.
Take a bit of time.
Excellent. Well, I can introduce myself while we're waiting for that to work. Hi, everyone. My name's Troy. I work for a company called Aiven, which we've already established that no one really knows what that is. Don't feel too bad. When I joined them about 12 months ago, neither did I. And that was part of the attraction for me to join. I've been involved in sort of open source technology in one way or another for most of my career, except for a brief stint where I spent some time slinging CRM at Salesforce. So that was my gateway drug to get me into Heroku, which some folks have probably heard as well. I'm an old Java developer by trade. Is how I got into it. And we used to do things like work on JBoss projects and stuff back in the day around Sydney. So I've been in the space around here for a while. What really drew me to Aiven, the company I work for now, we operate open source data services in public cloud. That's your cloud or ours, and across the 3 hyperscalers. So we really like to talk to our customers about being cloud agnostic and technology agnostic, and that's that big commitment to open source we have. You can see I'm rambling on because my slides still haven't shown up. What's interesting about that is it allows our customers to get all the benefits of managed services, but without that vendor lock-in. We do not run anything in our platform that's not completely open source. And so that means if you run Kafka or OpenSearch or all these other services that we've got that I'm hoping to show you some tonight, you can one day, whenever you feel like it, download that project and run it on your own, VM, PC boxes, or whatever you feel like you want to run it. It's kind of a neat little place in the world to land. We're based out of Helsinki in Finland, which is a new and wonderful experience. If anyone's ever worked for a Finnish company before, slightly different culturally. Let's start doing some different things here and see if we can make something work, because that is not happening. So just, again, bear with me a sec, folks. Let's get out of that. Get the guys that know involved.
Hey, you joined us meeting?
I did, and there was nothing happening, so I unjoined. Let's try again. What was my code again? It's died. It's died. It's gone to the big Google Hangout in the sky. Okay. Yeah, now I'm asking to join. There we go. Let me in. Don't deny me.
Yeah, that's what a good sign. Someone wants to join the meeting.
Yeah. Yes. Yeah, can someone let me in? Now I'm knocking on the door. What we're going to talk about tonight, just a quick show of hands. If I say the phrase CDC, does anyone know what I'm talking about? Excellent, excellent. If I say things like Postgres, you can see I'm starting easy here. Kafka Connect, Debezium, ClickHouse. All right. That's the general arc of what we're going to try and squeeze through in 30 minutes. And the idea behind that, there's things happening here. Let's try again. Oh, it's making noises. Hey! And that is the end of my presentation. Okay, so I've talked about that. We talked a little bit about what Aiven does. Here's the slide that we run all those open source data services. The idea behind what we do is we want to provide a full open source data platform to software engineers. We've got 2 big mission statements at Aiven. One is to make developers' lives easier. You can see, well, there's a lot of ex-Heroku folk here in this company now as well. And 2, to make sure that we as a company can give back to open source communities. The founders of this company were actually committed to the Postgres project. One of them still is, I think. And so, yeah, it's kind of nice and cool. And we'll show you some of that technology today. What we're going to build today is this. Okay, so I think I shared the wrong thing, so you'll just have to bear with me. Let's do that one more time, because I did want to show you my entire screen. Look at that. I'm confident now. Okay, let's go and build all that. Okay. So while Terraform goes and does its thing, we're going to go and walk through some slides, and we'll come back to that in a little bit. We're building that stuff live as we speak, and that's what we're going to build. The idea behind it is there is a little piece of Golang code. Please don't judge my Golang skills whenever you download this repository. That's simulating 1,000 different coffee shops around Australia placing orders. So we're going to take a real-time feed off our production database, which is Postgres, which is taking orders for coffee drinks all over the country. We're going to stream that into Kafka, and then it's going to, through the magic of change data capture, end up in an analytics database called ClickHouse. So let's talk about some of those things. So I'm glad we can skip through some of this because everyone said yes. Change data capture. It is a design principle. Some really interesting use cases that I've seen out in the wild about this that some may call common is what we're doing at today, right? Streaming data changes for analytics purposes. Compliance and audits are really interesting use cases for change data capture. It's probably the first time I heard of it was in a compliance perspective, who's changing what and when. Database replication is listed as a use case in here, but if you're using Postgres, I would suggest that maybe that's not the greatest use case of what we're set up today. There's better ways to do that in Postgres. And then there's an interesting sort of time data personalization use case that I've definitely seen starting to emerge around here. Like you've got a stream of data off your web platforms that people are making commitments to the database that you can then change their experience on your front end platform in a personalization engine. But it's essentially this: change happens, gets sent to another place that cares about it. Typically, there's 3 ways this has been done. The first way, since Postgres 9.1, the community has provided a function, which is essentially just a trigger that says any table that gets changed, record that change in another table. Has anyone written Postgres triggers before and run Postgres triggers in a database? So you know all the fun things that can happen there. There's a couple of problems with that. One is you've got the performance and fun things about triggers from a maintenance perspective. Triggers are just, anyway, entropy in my humble opinion. And then you've still got to get that data out of that database, because all you're doing is just writing into your database. So you've got a production database that you're making bigger, using all the loads and all that kind of stuff. So it works, but it might not scale. The second thing that people might do is just be like, you know what? We've got a last updated flag on our table, and every some random amount of time, we can query that and say, give me all the data that's changed since the last time. You'll get records that's changed, but you run risks in that world of your granularity on time being too big and missing changes in between. So if I update a record 4 times, do I get all 4 of those things? Okay, and so that's for the compliance audit use one. You're going to increase the query on your server. Depends on what you do with your server. That's or not. And what are you going to do with the results of that query? Like that's now on you. Congratulations, you've got the results of the SQL query. But what are you going to do with it? And the third way, which we're going to talk about, which we're busily building at the moment, is replication. So since 9.4 it was Postgres, they had this set of database replication into the database. We'll talk about those things as well. And this uses logical replication feature inside Postgres. And it is just a method that's, big tick from how you follow changes in the database. And pretty much, okay, so I'm some of the, because Postgres survives catastrophic failure of hardware. Okay, and basically all the write-ahead log does in a database, to overly simplify it, is it says, before I write it to disk, I'm going to write it to this append-only log because it's faster and it's easier. Once I've got enough of those in the log, I can then write that to disk because that's slower. And it means that I can get something written down and stored as fast as possible to commit the transaction back to you and know that that transaction is good. Now that I have a log of all the changes, I can take the last known state of the database, apply that log in order, and get to the state of the database it was. And this is how Postgres backups typically work in most managed services. It uses this thing. When you start to dive into this, you'll hear this word called logical replication. So now we're going to use the write-ahead log to copy data from one database to another. And so if you need to take backups of Postgres, this is how, this is definitely how we do it at Aiven, and this is probably how everyone does it these days, to be honest. But this is definitely how we do it. We use logical replication. and you can set up 2 Postgres databases of different versions, and this is the difference between physical and logical replication. But you can set up 2 different databases to say, here's a set of tables, get the write-ahead logs and make sure that that data is copied around. To give you an indication of how performant this is, we talk in our documentation about our read followers, which use this mechanism for replication, of being less than a second behind the primary database. So it's very efficient. It's a really good way to copy data around inside Postgres. Cool, everyone still with me? Excellent. Last, when we get into the details of Postgres, when you're in that world, you've got a publication and a subscription. It's probably self-evident what they are. You publish a set of change that you want to track in one database. You have one or many subscriptions in other databases. The subscription pulls data from the publisher. Okay, so it's a pull. You put the connection strings inside the subscription. This is all just general information, by the way. And when we get to the bit about Debezium, it does all this for us. Okay, this is one of those things. You know about this when you're trying to figure out why it's not working. These are the things you have to go and look at. And this is where we sort of lead into Debezium. This is the nice little piece. It's sort of the bit that ties Kafka Connect and Postgres together. The community went, this is such a common use case. We want to stream events out of databases, and they had Red Hat, I think, were the original folks that created Debezium. It's now a fully open source project. They were? Oh, so I thought you were disagreeing with me.
Oh, no.
No, you're agreeing with me. Well, you can agree with me loudly. Yeah, so this is sort of what we're going to do. I like diagrams like this. It makes things look simple. This is what it actually is that we're deploying, not quite as simple. But inside, like you'll see, like I think I titled this presentation, The Things I Needed to Learn to Build This Presentation, right? Because I'll be very honest, 12 months ago, I knew nothing about this. And this was the bit that really twisted my head the most. And because I started here, I went, oh, I've just got to plug Debezium in. And I'm like, what do I have to put in that plugin name? What's a slot name? What's all that stuff? And so you sort of, as soon as you start to do Debezium, you dive into the details of Postgres reasonably quickly. They do these for MySQL and other databases, SQL servers, and all sorts of stuff. And they've all got slightly different ways of doing replication. The things here, because I think we'll publish these slides. If ping me somewhere on one of the socials if you want them. I'm happy to give them to you. Is those two sort of that transform? That's a Kafka Connect property, this single message transform. I just highlighted it here because when we look at the data that we're pulling out of this particular database for the demo, that's the bits that make the data nice and easy and clean. An actual Debezium envelope's got like an initial state. It'll tell you if it's a create record or an update. It's got a lot of interesting metadata around it as well, which quite frankly just made my ClickHouse queries really hard. So I got rid of it. Okay, that is Postgres. All things we need to know about Postgres to do this. That is Debezium. Now we're going to talk about Kafka. We're going to come back to the things that we all know about, which is nice. In a Kafka, it is a streaming platform. You have producers and consumers of events. An event is is probably the most sharpest, distinct way I can describe that. I think everyone knows this these days. Developed at LinkedIn and been open source for over a decade now. Without a doubt, the leading streaming platform worldwide, without a doubt. It is not a database, all right? I have customers that treat it like one. We're happy to take their money. It's not a database. So yeah, there's better ways to store data long-term. Things you use it for, the most common thing I think that I see is still this event broker. So if anyone's building microservice architectures, like a communication layer for a microservice architecture is quite often a good thing for Kafka. There's all sorts of things, activity metrics, logging, tracking, all that kind of stuff. Anytime it's streaming ingestion you think of, this is really good. Some things you'll hear me talk about today: topics, petitions, and offsets. A topic is a set of events. That's enough for what we want to talk about. It's split into petitions, which have implications about where it's written to on disk and how you process it and high availability and all that stuff, but a petition is part of the topic. Events are processed in order within a petition. That makes no difference to what we're about to talk tonight, but it's in there. And an offset is the number of the message you're at when you're processing it. And that's one of the interesting things, because Kafka's really nice. It hides all this complexity in the clients and the producers. So when you download a Kafka library, all this stuff's happening underneath the covers, which is quite nice. Like your consumer, for example, you don't have to write back to Kafka what offset you're on. Kafka actually automatically remembers that for you, and it makes the developer experience a little nicer. Producers, right started to topics. It does what it says on the tin. There is some semantics about message delivery, at-once delivery, acknowledgement. This sort of acknowledgement on how producers react when they have messages. It's just like when you send a message to Kafka, you basically wait for it to tell you that it's got the message and it's written to the bus, i.e. it's persisted. And these things are multiple nodes, like multiple broker nodes, and that's why they're always fun to run in production, because you've got plenty of computers across availability zones and stuff typically. And so you can say, look, I don't even care if you've got that message. I'm sending you so much data, I can't wait. I'm just going to trust it. You could be like, I'm just going to wait till one of the brokers has got it, and that's enough. Or you can wait till all the brokers that replicated that message has got it. And that's your HA consideration as an engineer or a producer, what you've got to think about. And it's the proper highly available versus throughput discussion that you have to have. Like, do you wait for everything to get copied around and be fully highly available before you move on, or do you want to squeeze some more throughput in there? Consumers, they do what they say on their tin. They usually work in groups, and we won't get into too much of that. Okay. The glue in between our database and our Kafka cluster are these things called connectors. So the Kafka community went, hey, this event streaming thing is really cool. I seem to go to work every day and write the same thing. Someone else has another database or another S3 bucket that they want to stream these events to. And so they created this thing called Kafka Connect. And Kafka Connect is a framework that allows software engineers to create reusable connectors. And now there's a whole library of reusable connectors that you can plug into this thing and say, hey, what we're doing tonight, I have a Postgres database. Can we just plug in a Debezium connector and get a data stream from it? Okay. If we wanted to, we could plug in a source connector and sync this out to an S3 bucket or to a Google Object Store or to OpenSearch or something. Right. That's what connectors are for. They're really, really useful. You can write your own custom connectors so that you can write your own code that extends the framework and run that in Kafka Connect. Full disclosure, you can't run custom connectors in the Aiven version of Kafka Connect. That's not something we let you do. These are sort of our most commonly used connectors that we support. There's a bunch of supported connectors, and that's always the fun conversation about managed services versus running these things yourself. Okay, we're getting through it. Okay. We've got the last thing to talk about, and so we'll take a little bit of extra time there because I think I saw the least amount of hands here. ClickHouse is, again, I sort of didn't hear about this till about 3 months ago when I heard that we were thinking about offering it as a product. There is a company in Russia called Yandex that I had never heard of that are apparently the second largest web analytics platform in the world. I imagine the first one is Google. And they've got this product called Yandex Metrica that takes metrics from web platforms everywhere. As you can imagine, if you're ingesting that much data, you need a specific tool to do that. And they figured that they needed such a specific tool, they built their own. And they built this thing called ClickHouse and quite graciously open sourced it for the rest of us in the world to enjoy. It is a columnar database. And I was looking around about how am I going to describe the difference between a row-based database and a column-based database, and I have to admit, the ClickHouse documentation had the best image to describe this. This is exactly why a column-based data store is so much faster for processing, because you don't have to scan every row of data. You can go and pick the columns you want, and the way that it's all organized on disk and under the covers we'll talk about is a bit quicker. But you scan a lot less data. Like you can scan billions of rows of data in ClickHouse, like query billions of rows of data, and you can get scan rates of like 0.5% of the total amount of data. And it is an insanely fast and efficient piece of kit. And so this is one of the sort of fun things about having a data platform. Is anyone feel it's just, yeah, we'll talk about some of the use cases, analytics, operational work. So like what we're doing today, this is a good kind of thing. You can think about it either as clickstream data or telemetry source through an event stream, and you want to put it somewhere and build dashboards on it. One of the really nice things about ClickHouse is custom dashboards. A lot of analytics tools charge you per query or per data scanned or something like that. When you run on a service like this, you've just got the computer and the data that you're storing, and so you can expose that to your customers without worrying that you might get a customer that hits that API 100,000 times a day, right? So you don't get charged on that per use kind of scan, which is quite nice. This is exactly what this product was built for. This is what Yandex does with it. It is excellent at it. We talk to our customers about, like, we've got customers that run multiple terabytes of Postgres, and we're in the process of saying, hey, how about you do that somewhere else? Because it's just much faster and it's much quicker. And so this is sort of offloading analytics workloads off operational databases just for performance reasons and stuff like that. And then some building metrics and stuff like that. We would do it with Grafana because we run Grafana, but obviously whatever you want to put in front of it for visualization is entirely up to you. And ClickHouse supports all these kind of things as well. It's pretty cool. It is a pretty cool piece of kit, and I thoroughly encourage people to have a look at it. Let's not talk about all the details. These are all hyperlinks if you want to dive into the why is ClickHouse so much better. There's a couple of things that are interesting, like the broad brush here is that ClickHouse was developed in 2016. And in 2016, things like parallel processing and multi-core processors, these things existed and the engineers thought about it. And so like it really takes advantage of the hardware that it runs on, like really, really well. It is like proper column orientated. And so there's definitely use cases that don't suit here. Do not delete from this database very regularly. Like it doesn't like deletes. It doesn't like updates. Really doesn't like updates. It does a whole bunch of wonderful things. I won't get into the detail. If anyone's super interested, I'm doing a talk that gets into some of the detail at a conference in Melbourne in a couple of weeks. We did a little benchmark just for giggles and mostly marketing purposes about running queries on a data set inside Postgres versus ClickHouse. And what we found, which was kind of cool, so we found this data set that was 4.5 billion rows of data on YouTube metadata. And it was kind of like the last snapshot of YouTube metadata after they stopped counting likes because people were going crazy. And so we grabbed that data set and then sort of ran these queries across it, loaded it into Postgres and loaded it into ClickHouse. What was super interesting is the underlying hardware we loaded it into, the ClickHouse service, was like half the size. Does a lot of wonderful things with data compression and stuff under the covers as well. So we actually needed like half the amount of disk space to run this service than we did on the Postgres service. And the results on the query response times speak for themselves and quite honestly were expected. So there is the bits about what we use. This is our characteristics of when you use ClickHouse. Large volumes of data, large ingest, mostly aggregations on wide columns with relatively small values. Like don't put blobs in ClickHouse. Don't put, like, it's not DynamoDB. It's like, don't put a big block of text in it. It's not OpenSearch. Like it's a use case driven thing. It's for aggregating data and ingesting in large amounts in batches. Like they talk about like 1 million records in an ingest is a good number to send to ClickHouse to ingest. Reads are great. Modifies and deletes. Like, if everyone's got to support things like GDPR, so obviously that's supported. But you want to do that once a day, or you don't want to do that every minute. I think I just said what was in that. It's not a DBMS. It's not file storage.
Just a question.
Yeah.
How does it perform with joins from one more code, so it's horrible.
Yeah, pretty good. Pretty good. What's interesting about, and obviously, depending on how good your join query is and how much you're going to join, but it's actually pretty efficient on the way that the query optimizer works in it as well. And it gets back to like it does a couple of things, like it splits the data set across all the processes and sort of like, so it does like really efficient parallel processing on your query at the CPU level, which is really noticeable. But I'm sure I could write a terrible join query and kill it. It's a talent I have.
I'm just thinking about
Yeah, right.
they basically come out and say, use mark tables rather than using traditional star scheme or something like
Yeah.
that, because it just doesn't perform as well as it should to joins.
Yeah, it would probably boil down to a use case. I feel like I've reached into the I'm taking questions section, which I'm more than welcome to do. Sorry. By the way, no, that's good. That's good. Did someone else throw their hand up there for a second? Was that you?
Like in Cassandra, we have to do the Cassandra repairs.
Yeah.
Is that something which is requiring because as well?
I don't think so, but I'm going to pause there because I haven't played too much with Cassandra, so I'm not 100% familiar with what you're talking about. It's on my list of services to learn because we operate it. I'm going down the list. Yeah. I wanted to jump in and how long have I got left? Where's my handler? Should I wrap it up?
If you've got a demo, we're happy to.
Look, no, turns out, no, I don't.
Oh,
My Terraform script didn't work. I'm not going to sit here and try and debug that in front of everyone. Who knows what happened? Underneath the covers, you can see sort of created a few things. This is what it looks like inside the platform. That's just always the way it works, isn't it? We just created those services. We run it in Amazon. It's all connected. This is one of the interesting things about Aiven. Is all these things are sort of automatically connected in our platform. Runs on our actually, this is running on our AWS account. And so the folks that have to look at data egress bills probably understand what that means. But yeah, I'm happy to pause it up there. I feel like I owe everyone a working demo, so I'll go back and make sure my GitHub repository is actually working. And I'll get make sure that works. If you want to try this yourselves, folks, I do have a GitHub repository that I think we've shared already, haven't we? But it'll be shared again. There's some prerequisites in here, like some jQuery and Terraform, and I think I've got the ClickHouse binary to do stuff to make that Terraform thing work.
I've actually just popped over your repo. I assume it needs an Aiven account.
Yeah. So
you guys do free trials?
Yes, yeah. So the trial in Aiven gets you $300 US. So it should cover you to do this kind of stuff. Oh, yeah. Actually, good finish. God, they'd kill me. You, for turning up tonight, can get $500. God.
Maybe full screen ads.
Yeah, the marketing folk would kill me. That is my last. So I'm going to take either questions or thunderous applause.
Always be selling, folks.
Yeah, thank you very much for having me and listening to me drone.
Any questions? Do you get steak knives with that?
Only if you pay for them. Yeah, like the last thing I'd say, like I said, it's a fascinating thing to dive into if you're interested in this kind of stuff. It was a little bit of work, but not as much as I expected. Like I said, like when I started on this journey, I did know nothing about this.
So for getting data out of Kafka, using that Kafka connector, do you need to write a code or is it just a configuration to see how to
Into ClickHouse specifically? Yeah, it's a good question. So in ClickHouse, this is going to be fun because I don't really know where it died. I'm going to go and find the code. Oh, I know where I can find that code. Okay. Let's talk about that. So in ClickHouse, you create a table. So ClickHouse has schemas, by the way. It's a schema thing. So this is the table that we're going to do our analytics from. And then we create this materialized view. Okay, and the materialized view, you notice, reads from a different service. It reads from the table that's created by the integration directly into Kafka. And that integration uses something that's called a Kafka engine. So ClickHouse has got integrations into both Postgres and Kafka in our platform. The open source version's got integration into all sorts of things, S3 and all that kind of stuff. And so you can use SQL and tables to reach into those things and pull it out. So what this does is just shows up as a Kafka consumer. And that's what the materialized view needs to do. So because it's a Kafka consumer, it'll only ever read that data once. So you need to read it, put it in a materialized view, and then read it from the table. So you can obviously read it multiple times. If you read it from where it gets initially read to, you read it once and then you're like, where's my data? That's the next part of the learning curve when you're in here going, what? But yeah, so that's how you sort of set that up. And there's data type mappings, all the data types you'd expect to be in databases live in here and stuff like that. You can do all sorts of transforms and stuff inside here. And you'll see that in my Kafka world, which here's a fun. This is always good, demoing things that didn't work to see where it got to. Yeah, that's my Kafka Connect didn't work. Yeah, the topics in here have data in them and stuff like that. Now it's not the best demo.
It is defense. He did fly all the way from Auckland this morning, right?
I got up this morning at 2:30 local, our time to come here.
Probably a tough ask. Was there another question?
Yeah, I just wanted to ask you, what would you recommend, because there's a lot of complexity to use with Kafka right now and everything else that you discussed.
Mm-hmm.
So at what point do you recommend people to use this?
Oh, that's an excellent question. I'll repeat the question in case you didn't hear it. It's like, it is a very complex kind of thing that I just walked through. That's a very good point. And when you work in tech, like the less complexity is the best. So when do we see customers adopt things like this? So there's, I'll make up examples because we're streaming. Okay, I'm going to use a company that we all know. They're not a customer of ours. Let's be really clear about this. Imagine everyone knows what Stripe does, right? This is the kind of architecture that may benefit them, right? It's very large. It's massive scale. They're not going to fit it in a relational database. That kind of, when you've got a lot of scale, I'm a massive believer of like Postgres, just quietly. If you can put it in a Postgres database, it's rock solid, it's hyper performant, it's very well backed up. Everyone knows how to use it. When it doesn't work in Postgres anymore, usually because of scale and like you want to separate concerns about data access and stuff like that, these things are good. Real-time personalization is another great example of where this works, like where you want to get that complexity. Changing a marketing audience. So picture a world, and there's products out there that do this as well. You don't have to build this yourself, but picture this world where you've got, I think we were talking about this before, who's bought a pair of shoes only to be advertised that same pair of shoes for the next 2 days? Right, it's the absolute bane of every marketing technology executive in the world, right? They're wasting money on that audience because there's no way you're going to go and buy another. This is what that would do. You could take a real-time, hey, that's a purchase event, and send that off to Facebook and say, take that out of that Facebook audience immediately and avoid that, right? There's definitely use cases, but yeah, don't do it just for fun.
You guys know what we do.
Yeah.
I'm sure your team will cover it in the next.
Yeah. Is that the next presentation? Ignore everything that guy said.
No, that was a round of applause.
No, thanks, folks. Thanks a lot.
Absolute treat for presenting tonight.
It was fun.
It
It was a lot of fun.
Flight in from Melbourne.
Auckland.
Yes.
Good friends of Aradar.
Yes. Okay. So up next, we've got the awesome folks from Rokt, Loiral and Harpreet Singh. They're going to talk about scaling Rokt's NoSQL